Hello everyone. Are you ready to dive into the fascinating world of physics? Today we're going to explore amazing concepts that shape our understanding of the universe. Before we begin, I would like to ask for your support. Please leave a like, subscribe, and comment below with the topics you would like to see in future videos. This helps our channel grow and continue bringing this content to you. Thank you. Get comfortable and let's embark on this journey together. So, what is physics? At its core, physics is the science that studies matter, energy, and the fundamental forces of nature. From the tiniest particles to the vastness of the cosmos, physics helps us unravel the mysteries of the universe. But don't worry, we'll keep things engaging and accessible, so you won't need a PhD to follow along. Let's kick things off with one of the most iconic theories in physics, Einstein's theory of relativity. Have you ever wondered how time can appear to slow down? According to relativity, time is not constant. It can be affected by speed and gravity. For instance, if you were traveling close to the speed of light, time would pass more slowly for you compared to someone on Earth. This mind-boggling concept has profound implications, especially in astrophysics and the study of black holes. Speaking of black holes, let's explore them further. Black holes are regions of spacetime where gravity is so strong that nothing can escape from them, not even light. This phenomenon occurs when a massive star collapses under its own gravity after exhausting its nuclear fuel. The boundary around a black hole is called the event horizon, and once something crosses this threshold, it is lost forever. Imagine how fascinating it is to think about the mysteries that might exist beyond this boundary. Now let's shift gears and talk about the quantum world. Quantum mechanics is a branch of physics that studies the behavior of particles at the atomic and subatomic levels. Unlike classical physics, where objects have definite properties, in the quantum realm, particles can exist in multiple states at once. This phenomenon is known as superposition. A famous thought experiment that illustrates this concept is Schrödinger's cat, where a cat in a box can be simultaneously alive and dead until observed. This paradox challenges our understanding of reality and observation. But quantum mechanics doesn't stop there. Another key concept is entanglement. When particles become entangled, the state of one particle is instantaneously linked to the state of another, regardless of the distance separating them. This connection puzzled Einstein, who famously referred to it as spooky action at a distance. Modern experiments have confirmed entanglement, paving the way for advancements in quantum computing and secure communication. But quantum mechanics doesn't stop there. Another key concept is entanglement. When particles become entangled, the state of one particle is instantaneously linked to the state of another, regardless of the distance separating them. This connection puzzled Einstein, who famously referred to it as spooky action at a distance. Modern experiments have confirmed entanglement, paving the way for advancements in quantum computing and secure communication. Let's not forget the wonders of electromagnetism. This fundamental force governs everything from the behavior of atoms to the functioning of electrical devices. Electromagnetic waves, which include visible light, radio waves, and X-rays, travel at the speed of light and play a crucial role in our daily lives. The principles of electromagnetism are what make your smartphones and computers work, allowing us to communicate and access information at lightning speed. Now, let's discuss the conservation laws that govern physical processes. One of the most important is the law of conservation of energy, which states that energy cannot be created or destroyed. It can only be transformed from one form to another. For example, when you ride a bicycle downhill, the potential energy from the height converts to kinetic energy, making you accelerate. This concept is fundamental in all areas of physics, from mechanical systems to thermodynamics. Speaking of thermodynamics, this branch of physics studies heat, energy, and work. The laws of thermodynamics explain how energy moves and transforms within systems. The first law states that energy is conserved, while the second law introduces the concept of entropy, indicating that systems naturally progress toward a state of disorder. This principle helps us understand everything from the efficiency of engines to the behavior of gases. Now let's explore the concept of chaos theory. At first glance, some systems appear random, but chaos theory reveals that they follow underlying patterns. The classic example is the butterfly effect, where a small change in initial conditions can lead to drastically different outcomes. This idea has significant implications in various fields, from weather forecasting to stock market analysis. Have you ever thought about how gravity works? Gravity is a force of attraction between two masses, and it's responsible for keeping us grounded on Earth. Sir Isaac Newton formulated the law of universal gravitation, which states that every mass attracts every other mass with a force proportional to the product of their masses and inversely proportional to the square of the distance between them. This fundamental force governs the motion of celestial bodies and the structure of the universe. Speaking of celestial bodies, let's take a moment to admire the beauty of stellar evolution. Stars are born from clouds of gas and dust in space, and their life cycles are fascinating. A star like our Sun spends billions of years in a stable phase called main sequence. Eventually, it will exhaust its fuel and evolve into a red giant before shedding its outer layers, leaving behind a hot core known as a white dwarf. Meanwhile, massive stars undergo a more dramatic fate, often culminating in a supernova explosion, which can create neutron stars or black holes. As we zoom out to the scale of the universe, we encounter the concept of the Big Bang. This theory proposes that the universe began as an infinitely hot and dense point approximately 13.8 billion years ago. As it expanded, it cooled, allowing particles to form atoms and eventually leading to the creation of galaxies, stars, and planets. The cosmic microwave background radiation, a remnant from this event, provides compelling evidence for the Big Bang theory. Now let's explore dark matter and dark energy. Though they constitute about 95% of the universe, they remain mysterious. Dark matter does not emit light or energy and is detectable only through its gravitational effects on visible matter. Dark energy, on the other hand, is thought to be responsible for the accelerated expansion of the universe. Understanding these phenomena is one of the most pressing challenges in modern astrophysics. Throughout history, physics has led to incredible discoveries and technological advancements. One of the most remarkable examples is the development of quantum mechanics, which paved the way for technologies like semiconductors and lasers. These innovations have revolutionized fields ranging from telecommunications to medicine, making our lives more connected and efficient. Now, let's turn our attention to the beauty of symmetry in physics. Symmetry is a guiding principle that helps scientists formulate theories. For instance, the Standard Model of particle physics describes the fundamental particles and forces that govern the universe. The model relies heavily on symmetry principles, and the discovery of the Higgs boson in 2012 was a significant milestone, confirming the existence of a particle that gives mass to other particles. As we approach the end of our journey, let's not overlook the significance of experimentation in physics. The scientific method relies on observation and experimentation to test hypotheses. Iconic experiments, like the double-slit experiment, illustrate the wave-particle duality of light and particles, demonstrating the strange behavior of quantum objects. This reliance on empirical evidence is what makes physics a robust and evolving science. Now, let's talk about a phenomenon that is equally impressive: gravitational waves. Predicted by Einstein in his theory of general relativity, these waves are ripples in the very fabric of space-time created by massive events like the merger of black holes or neutron stars. In 2015, scientists from the LIGO project detected these waves for the first time, confirming a prediction by Einstein that was over a century old. This discovery not only gave us a new way to observe the universe but also opened the door to an entirely new field of research in astrophysics. As we continue our journey through the cosmos, we cannot ignore the concept of dark energy and dark matter. While we cannot see them directly, we know they account for about 95% of the universe. Dark energy is responsible for the acceleration of the universe's expansion, while dark matter, which does not emit light or radiation, exerts gravitational influence on visible matter. The search for understanding these mysterious entities is one of the great questions of modern physics and involves sophisticated experiments and astronomical observations. Beyond the vastness of the universe, physics also applies to our daily lives in unexpected ways. A clear example is thermodynamics, which studies how energy transfers and transforms. Have you ever noticed how an air conditioner works? It removes heat from the indoor environment and expels it outside, using the principle that heat naturally flows from warmer areas to cooler ones. This process is a practical example of the second law of thermodynamics, which states that the entropy of an isolated system tends to increase over time. Another interesting concept is air resistance. When riding a bicycle or driving a car, you are facing air resistance, which opposes motion. This resistance increases with speed. That's why cyclists crouch down to reduce the area exposed to the wind, minimizing resistance and saving energy. This leads us to consider aerodynamics, the science that studies how air moves and interacts with objects in motion. Innovations in vehicle and airplane design are constantly optimized to minimize air resistance and increase efficiency. Physics also infiltrates our lives through sound phenomena. Sound is a wave that travels through a medium such as air, water, or solids. When you speak, your vocal cords vibrate, producing sound waves that travel to your ears. The speed of sound varies depending on the medium. it travels faster in water than in air. This principle is essential for various applications, including sonar technology used by submarines to navigate underwater. As we conclude our exploration of physics, remember that it is not just an abstract field. It's a vital part of our understanding of the world and the universe. Each concept we've discussed, whether it's relativity, quantum mechanics, electromagnetism, or thermodynamics, has paved the way for advancements in technology, medicine, and our comprehension of the cosmos. Thank you for joining me on this exciting journey through the realms of physics. If you enjoyed this video, please give it a thumbs up, subscribe, and hit the notification bell to stay updated with our latest content. Let's continue exploring the wonders of science together. See you next time.